All right. Good morning. Today we're going to talk about stoichiometry and leftovers. On Friday, you went to the library and you worked in a computer simulation in a sandwich shop and discovered, oh, sorry, that was a big yawn. What happens if you have too many pieces of bread or too many pieces of cheese? Those are the leftovers. In stoichiometry, we refer to leftovers as well, the leftovers are the excess, but the limiting reactants are the reactants that get used up. And the excess are your leftovers. All right. For instance, if you're making s'mores and you have a bag of marshmallows, so you discover you have 30 marshmallows, and you have 20 whole graham crackers, and you have 10 chocolate bars, whole chocolate bars. So, how many marshmallows can you make, or how many s'mores can you make with the marshmallows? If you put one marshmallow on each s'more, you can make 30. 20 whole grams, if you break them in half, but still one whole one or two halves gives you the number you can make, you can only make 20. The chocolate bars, usually you break into thirds. So if you break your chocolate bar into thirds, then you would be able to make 30. So what's limiting here? The graham crackers are. Okay, that's all we're talking about here. Only we're going to talk about chemicals. All right. How to figure out limiting and excess reactants. First, you balance. Then you calculate the number of moles from the mass. Use your mole map. Then you use the stoichiometry factor to do it. Here we go. You have 20 moles of glucose. I'm going to write 20 moles above glucose and 15 moles of oxygen. How much carbon dioxide will you make? This is what we want to know. But we can guess, but we need to actually do some math here and figure this out. I'm going to write it down here at the bottom. All right, so the first thing you do is calculate how much will carbon dioxide will 20 sugars give and how much carbon dioxide will 15 oxygens give. So starting with sugar, glucose, 20 moles of sugar and it's a 1:6 ratio. 1 mole of sugar gives you 6 moles of carbon dioxide. You get 120 moles of carbon dioxide. Not bad. Not bad at all. All right, let's try oxygen. 15 moles of oxygen. And our ratio of oxygen to carbon dioxide is 6:6. 6 moles of oxygen to every 6 moles of CO2. So 15 moles of CO2 are all we're going to make. Okay? What's smaller? The oxygen, or the carbon dioxide made from 15 moles of oxygen. So this is our limiting factor right here. All right. Now, the next thing you're going to do is figure out how much of the sugar you are going to use up. The way you do that is you're going to start with moles, 15 moles of oxygen, and you're going to go to calculate how much sugar you're going to use up, how much glucose. So we're going to use a ratio of oxygen to sugar, 6:1. So for every 6 oxygens, 1 glucose will be used, and we get 2.5 moles of C6H12O6 that will be used. Now, if I want to know excess, I have to know what I started with. I started with 20 moles of glucose, and I used 2.5 moles. So what's left over? 17.5 moles of glucose. All right, so let's try this one. And you guys work along with me. How many moles of ammonia will be made if you have 5 moles of hydrogen and 2 moles of nitrogen? So first deal, 2 moles of nitrogen. What's my ratio of nitrogen to ammonia? 1 mole of nitrogen to every 2 ammonias will make 4 moles of ammonia if we start with 2 moles of nitrogen. If we start with 5 moles of oxygen, our ratio of, hydrogen, our ratio of hydrogen to ammonia is 3 to 2. And we will make 10 divided by 3, 3.33 moles. So what is smaller, or what's making a smaller amount? The hydrogen. Hydrogen is limiting. Okay, so we'll figure out excess now. 5 moles of hydrogen, and we want to know how much, I'm sorry, did I say hydrogen? Yes. We want to know how many moles of nitrogen we're going to use. Our ratio is 3 to 1. 3 moles hydrogen to 1 mole nitrogen. .67 nitrogen used. How much do we start with? Started with 2 moles. Minus 1.67 gives us 0.33 moles of nitrogen left over. Okay. Try the next one. How many moles of hydrogen are produced from the reaction of 3 moles of zinc and 4.5 moles of hydrochloric acid? Start with the zinc. 3 moles, of zinc. Ratio of zinc to hydrogen gas is 1 to 1. 1 mole of zinc will produce 1 mole of hydrogen gas. So we're going to end up with 3 moles of hydrogen gas. All right, now we'll do the hydrochloric acid. 4.5 moles of hydrochloric acid. It's a 2 to 1 ratio. 2 to 1 ratio. 2 moles of hydrochloric acid to every 1 mole of hydrogen. And that would be 2.25. I'm getting a phone call. I'm going to put you on hold. Please hold. And I'm back. That was Mrs. Epps. She's doing the same thing I am, and I had to help her use the smart board. Okay, so where were we? 3 moles of hydrogen and 2.25 moles of hydrogen, which is limiting. Our hydrochloric acid, is going to be the limiting factor. Okay, so now we know what's limiting. We need to calculate our excess. How do we calculate excess? Well, we're going to use 4.5 moles of hydrochloric acid, and we're going to calculate the amount of our excess product zinc that we're going to use. So our ratio of hydrochloric acid to zinc is 2 hydrochloric acids to 1 mole of zinc. So 4.5 divided by 2 is 2.25 moles of zinc used. How much did we start with? We started with 3 moles. We used 2.25. So we have 0.75 moles of zinc left over. Okay? On to the next one. Propane plus oxygen gives you 3 carbon dioxides and 4 hydrogens. How many moles of carbon dioxide gas are made if you have 5 moles of oxygen and 4 moles of propane? Okay. Once again, we'll just calculate. First, we'll start with propane, 4.0 moles, C3H8, and our ratio of propane to carbon dioxide is 1 to 3. And that gives you 12 moles of carbon dioxide. Okay, let's try the other one. 5 moles of oxygen, and our ratio is 3 to 3. 3 moles of oxygen to 3 moles of carbon dioxide, and we have 5 moles of carbon dioxide produced. Clearly, oxygen is limiting. So if oxygen is limiting and propane's in excess, how much excess will we have? Well, we use 5 moles of oxygen, and we're going to look at our ratio. 3 moles of oxygen are used for every 1 mole of propane. 1.67 moles of propane. That's what we used. We started with 4.0 minus 1.67. What's left over? 4 minus 1.67, 2.33. Of propane in excess. Last one. How many moles of potassium nitrate are produced when 2.5 moles of potassium phosphate reacts with 4 moles of aluminum nitrate? How many moles of potassium nitrate are produced when 2.5 moles of potassium phosphate reacts with 4 moles of aluminum nitrate? So first, we have to calculate potassium nitrate. 2.5 moles of potassium phosphate, and our ratio here is 1 to 3. 1 mole of K3PO4 to every 3 moles of KNO3 will give us 7.5 moles of KNO3. Okay? Now, we'll do it again using 4 moles of aluminum nitrate. 4.0 moles of aluminum nitrate, and our ratio again is 1 to 3. So this time we get 12 moles of potassium nitrate. So our our potassium phosphate is what's limiting. Now, to calculate the excess, we're going to solve for how many moles we'll use of aluminum nitrate if we start with 2.5 moles of potassium phosphate. One mole of potassium phosphate for every 1 mole of aluminum nitrate. So we'll use 2.5 moles of our aluminum nitrate. How many did we start with? We started with 4 moles. 4 moles minus 2.5 gives us 1.5 moles left over. All right, so we've got a worksheet today, fairly simple. Give it your best shot, and we'll go over the worksheet tomorrow. See you guys later.